Hello, I'm Ahmet, and today we will talk about how you can beam up your GenAI usage. We will talk from lessons from Apache Beam about usability, reliability, and efficiency. What is Apache Beam? Apache Beam is a data processing framework. It's open source, it's part of the Apache Software Foundation, and has growing usage. And why is it relevant to this community? Because it offers a balanced view of correctness, latency, and cost, and at the same time it has proven itself in cloud, on-premise, and hybrid environments. It also has been heavily used in the machine learning community, and we will talk more about this in this talk. Beam's machine learning journey started in 2017 with TensorFlow Extended. This is an end-to-end machine learning framework. It brought industrial-scale machine learning to Alphabet. Today, TFX pipelines run at Alphabet every day, powering hundreds of millions of inference decisions. And at the same time, TFX has adoption outside Alphabet with large tech companies like Airbnb, PayPal, and X. However, outside Alphabet, there were some headwinds to the adoption of TFX. One of them was TensorFlow was not the only machine learning framework. And at the same time, growing in a diverse set of user base demanded something easier to use. And demand for GPUs and accelerators in general was increasing, and the cost and availability of these devices are limited. And finally, as the number of machine learning frameworks and applications grew, the required costs for ongoing maintenance were increasing, taking time away from core ML tasks. BeamML came to address these problems. It is based on the lessons that we have learned from Alphabet and thousands of small to large scale companies. It offers a standard set of tools to enable machine learning at scale for streaming pipelines. The emphasis on usability, reliability, and efficiency. And it has significant usage growth since 2022 with marquee use cases like Spotify using BeamML to power podcast previews, and they have seen 30 times speed improvement there. Similarly, Credit Karma powers 20,000 features, 200 plus models, and serves inference recommendations for their 100 plus million users using BeamML. Taking a deeper look into the Spotify's ML use case, they have been able to reduce this 110-minute podcast preview timeline to under 4 minutes, and that's impressive. But when we look deeper under, we will see a bunch of enterprise requirements. These requirements are centralized ML, explainability, MLOps, and enabling different teams to work with each other. In short, they were looking for an end-to-end ML platform rather than a single ML tool, and BeamML excels at this, it shines in this area. And before getting deeper into the BeamML, I would like to introduce myself. I'm Ahmet Altay. I'm a member of Apache Software Foundation. I'm a director at Google Cloud Dataflow. I like open spaces, open source, Python and data, streaming my hair, and I would like to hear from you, and these are some links to reach out to me after this presentation. Going back to BeamML, BeamML is built on top of three foundational aspects: usability, efficiency, and reliability, and we will do a deep dive on each one of those. At the same time, it offers a rich set of features for ML practitioners. For example, it offers ML predictions with remote or local models with efficient hardware use. It integrates with LLMs. It offers vector DB integrations, integrates with open source LLM frameworks, and at the same time, it generates embeddings for a number of different frameworks. Similarly, it integrates with ML frameworks and platforms like Hugging Face, TensorFlow, PyTorch. It integrates with a number of continuous data preparation tools like TFX and Kubeflow. Finally, it integrates with a number of connecting systems like Kafka, PubSub, BigQuery, etc. to make it easy for you to access your data from anywhere. Let's look at foundations in a deeper way. BeamML is easy to use. So this is a typical streaming ML pipeline. In a streaming ML pipeline, an ML practitioner wants to read data, process this data, to inference on this data, post-process it, and pass the information into downstream systems for activation. And each of these pieces might become a complex software by itself. Beam offers a number of great primitives to address this. However, for an ML practitioner, this might look like the Lego blocks on the left, while they are trying to create this Lego car on the right. As much as it might be fun, and there might be plenty of documentation, what we have seen in practice is people rewriting the same code over and over again, and they are adding inefficiencies and incorrectness as they are rewriting and repeating the same things. Our first key insight here was we would like to introduce common pipeline patterns in a single line, easy-to-use declarative fashion. A first example of that was run inference. Run inference by a single line of code allows you to run any amount of inference workload at production. It works as simple as by taking a declarative syntax to define where your model is and what are your model parameters. It is integrated with a number of machine learning frameworks. It's also integrated with a number of machine learning model repositories. And by using run inference, you can easily do prep and post-processing by adding single-line Lambda functions. And similarly, exception handling and BeamML is exceptionally simple by adding another single Lambda function to run inference to handle any type of error that you might encounter in your production pipelines. By bringing all of this pipeline of read, preprocess, inference, post-process, and activate, each of them become a single line of code. And this is a lot simpler than writing giant pieces of software for each of these boxes. Going deeper into the use case that we have started with, the Spotify use case, it was mentioned that they were using more than 6 models with more than 4 different frameworks. Each of these blue boxes you see in this screen is a model. And this is a true spaghetti in production. And BeamML actually makes it easy to manage this one as well. For example, you can add a single model line to pass your data into 2 different models in parallel. Or you can combine your models in a sequential manner. You can even introduce pre-processing or post-processing functions in between. And if you want to do even more complex things like A/B testing, run inference allows you to very simply pass the same data into different models based on a key. Going back to our original example, inference is only part of the puzzle. We would like to solve other parts of the LLM pipelines, for example, integrations with vector DBs or embedding generations. And BeamML offers out-of-the-box solutions for these ones as well. For example, ML Transform comes with tens of out-of-the-box solutions to do your pre-processing and post-processing. ML Transform also integrates with any number of embedding frameworks that's out there. And similarly, Enrichment Transform, as the name implies, could enrich your data, connecting to a key value store, and it will handle all the productionization and scaling aspects of this enrichment work. To wrap up all of this, BeamML is easy to use, and why? The reason is we offer declarative turnkey transforms. These transforms encapsulate really complex use cases like live model updates, support for multiple models, with a few lines of code. It serves different parts of the ML lifecycle: pre-processing, post-processing, and inference. It also allows you to combine all of these aspects in simpler pipelines. It integrates with all major frameworks, feature stores, tools, and libraries. It's also production-ready out of the box. Error handling, comprehensive metrics, dead letter queues are all part of the system out of the box, therefore making it really easy to go from experimentation to production with a single line of code change. The next foundational aspect we'll talk about is efficiency. BeamML is efficient. Starting from the problem, hardware is hard. What we heard from users like Spotify, they are swapping models in and out of memory to fit in small GPU memories, and they are compromising on pipeline visibility. At the same time, the cost of running a large number of GPU machines year-round is elevated. For Alphabet, administrative cost of running pipelines with tens of TPUs is high. And similarly, for Credit Karma said that running models sequentially, one at a time, resulted in excessive compute costs. And how could BeamML help with this problem? BeamML works with GPUs natively. It will bring your models into where they belong, GPUs, and it works efficiently whether you have small models. It will bring your small models, position them right next to the processes. Or if you have a single large model, it will put at its own process space and give efficient and easy access across workers. Therefore, it prevents duplication of the large memory footprint. And this equally works well with multiple models. Another place where BeamML helps is right fitting for GPUs. In a typical machine learning processing pipeline, you will see parts that benefit from small workers, that will be parts that really require GPUs, and there will be parts that will require high memory machines. One option here will be to run all of this pipeline in a single environment with the maximum amount of resources, but this will waste resources. Another option will be breaking down this pipeline into 3 pieces: a small worker piece, a GPU piece, and a memory piece. But doing this is error-prone, manual work, and also requires a lot of effort from the user. BeamML makes it really easy by automatically identifying parts of the pipeline and using separate worker pools depending on the resources that's required. In this example pipeline, the first part will run with a worker pool that has small workers. The second part will run with GPUs, and the last part will run with high memory machines. By doing this, BeamML automatically increases the utilization of your GPU worker pool and also addresses the problems with availability related to GPUs. To bring this all up, BeamML is efficient out of the box. It does a number of things automatically for you. It can solve the complex operational problem of memory management, whether you have small models or large models. It will efficiently load, switch, share, use different models as needed by a given pipeline. It will maximize the utilization of scarce and expensive resources, GPUs, automatically. It will use GPUs only where it's relevant, where it will make sense, therefore increases the utilization of your GPU pool. Finally, it will use best practices for cost and latency optimizations automatically. For example, BeamML will dynamically batch elements based on the runtime characteristics of your pipeline. So that you don't have to think about batching, this will be done automatically for you. And finally, BeamML is reliable. Going back to another use case here, Credit Karma. What we heard from Credit Karma is that they are building a self-service machine learning platform. They would like to enable hundreds of data science teams to come and onboard Credit Karma's internal self-service ML platform. Before BeamML, they were experiencing up to weeks to onboard different teams onto their system. And they were experiencing data latencies up to days, and that was reduced within under an hour with BeamML. Finally, with BeamML, they were able to reduce the time to go from experimentation to production to just under seconds. After they have adopted Apache Beam for their internal self-service ML platform, they increased their internal usage by 2x. And how does Beam help with reliability? One piece that Beam helps with reliability is that it helps with reducing the number of concerns that a ML practitioner has to think about while they're running a pipeline. In a typical do-it-yourself platform, a user has to have a concern for their business logic, that's the green boxes in this picture, and they also have to think about how to read data, write data, and they also need to understand the underlying system that's running. In a managed service might take care of more of these concerns and move it to the service provider's domain. But in a typical managed service today, still reading and writing data will be within the domain of users' concerns. What Beam offers is something called managed transforms. Beam could manage complex I/O transforms for the users and move the responsible to service provider's domain. In this world, a user will be only responsible and concerned about their core business ML logic, and they can defer everything else about reliability and monitoring and management of the service to the service provider's domain. Next thing, we have dependency management and with automatic driver installations and configurations. This might sound like a small problem, but what we have seen in practice is that this is a source of inefficiency and friction point for lots of users. Lots of users run with bad GPU configurations or spend lots of time trying to install the right GPU drivers at any given time. Beam manages this piece automatically for our users. Finally, it's possible with run inference that users can automatically update their streaming pipelines without stopping their streaming pipeline. What we mean by that is that your users will change, your model will change, your data will change, and you will want to update your system. In a typical environment, you will need to stop your environment and rerun with the new model. In Beam, you can update your pipeline or update just the model part of the pipeline without stopping anything. Beam offers a few options here. One option that it can watch for changes in a model, or it can wait for certain triggers to happen from you to go and fetch an update. To bring it all together, BeamML offers a reliable out-of-the-box offering for you. It makes it easy with declarative IOs and moves the concerns of complex and moving pieces into the domain of service providers. It makes the dependency management really easy, and it chooses the best drivers and best configurations on your behalf. Finally, it really makes it easy to manage and update running streaming pipelines, including running streaming pipelines models. And why all of this matters? So let's sum it up. One, BeamML has been growing significantly in the past 2 years. With Credit Karma, we have seen that the scale of data processing has grown 2 times since they have adopted Apache Beam. At Alphabet, we have seen that processing of millions of examples across thousands of TPUs without any administrative intervention, and BeamML is today powering Gemini, Edge, Waymo, Nest, YouTube, and other parts of Alphabet as well. Finally, in the Beam community, we have seen a huge spike in interest. Just in the last year, we have seen a 5 times increase in the BeamML-related talks compared to the year before. And what can you learn from BeamML and what can you apply to your own journey? First, building a platform that evolves as fast as your users and ecosystem will make your life easy. ML is a fast-growing and fast-moving ecosystem. If you pick a declarative style, capturing intent, you will give yourself the most flexibility to evolve your platform. Second, build for your users. This is easier said than done. You may not be your ideal user as well. We have made that mistake with BeamML. We started with Google Scale. We tried to apply it to the typical GCP experience, but it didn't really exactly fit. Understanding your users and building a system for them will be one of the highest priorities to build an efficient platform. Next, you will want to enable your users to focus on what matters most to them. We are talking about ML practitioners. They will like to focus on building ML-related pieces. Move concerns that are unrelated to their core tasks from your users to your site. Alternatively, you can just use BeamML and let us do the work for you. And what is next for BeamML? So we have so far talked about how we made Beam usable, reliable, and efficient. We have talked about a couple of techniques that we have applied along the way. One of the key pieces that we have talked today was turnkey transforms. Turnkey transforms allowed us to encapsulate these complex use cases and give users single-line declarative syntaxes to handle giant parts of their streaming ML journeys. Next up, what we would like to do is we would like to move from turnkey transforms to complete turnkey solutions. A couple of things that we are working on today is one, real-time recommendations. We would like to give users a chance to combine live data with some historical data and provide this as a single solution. Similarly, anomaly detection. A similar idea, we would like to combine telemetry data with certain historical data, detect anomalies, and offer this as a single out-of-the-box solution. And finally, we would like to build a financial time series index building. A similar idea applies there. We would like to combine current ticks with some historical information and provide information that is applicable and usable in the financial industry. With that, I will wrap up my talk, and here's a couple of resources that you can follow on. First, you can try Beam in your browser today. You can go to that link. If you would like to learn more about Beam and how it's used in production today, you can read more in the case studies section. If you would like to join the community, we would love to have you here. Here are some links. Also, we have a summit coming up in September. Finally, if you would like to play with examples and samples, there are a bunch of documents. Thank you for coming and thank you for listening.